Alright guys, so today we're going to look at 5.1b, but first we're going to finish this problem, which I probably should have done on the other video, but here we are. And if you were in class with me for the 5.1a, we may have done this, so you just ride with me through this. So here, remember it ends in 0, so that means 10 will work, okay? And 10 breaks down into 2 times 5. Both of those are prime, so we can stop there. Okay, then let's add up these digits. 1 plus 5 is 6. 6 and 6 is 12. So 3 will work, but 9 won't. It ends in an even number, so 3 and 2 work, so that means 6 will work. So you can use your calculator to see how many times 6 will go into it. And 6 will go into 156 26 times. Okay, so 6 breaks down into 2 times 3, both of which are prime numbers, so we stop there. And then 26, 2 will go into that 13 times. Both of those are prime numbers, so we can stop. So what we have is 2 times 2 times 2 times 3 times 5 times 13. Or the reduced version is 2, or the simplified version, I guess you would say, 2 to the third times 3 times 5 times 13. And you could work this out and just double check that that does give you 1,560. Alright, so for today's lesson, greatest common divisors and least common multiples, or GCDs and LCMs. So, today we're looking at greatest common divisor of two natural numbers is the largest natural number that divides both numbers. For small numbers, you can find the GCD by looking at the numbers and identifying the largest number that divides into both numbers. So let's look at this for example. So I listed numbers that go into 24. 1 goes into 24, 2 goes into 24, 3 goes into 24, 4 goes into 24, 5 does not, 6 does. 4 times 6 works, so that means that we can just mate them now. So 3's mate is 8 to give us 24, 2 and 12, 1 and 24. So when you get to the point that you have mates side by side, then you know that you can just finish them out. So 1 goes into 40, 2 goes into 40, 4 goes into 40, 5 goes into 40, 6 does not, 7 does not, 8 does. 5 and 8 make 40. So now we can mate them out. So 4 goes into 40 10 times, 2 goes into 40 20 times, and 1 goes into 40 40 times. Now, the biggest number that they have in common is 8. So that's what you can do when you have small numbers. For larger numbers, it's tedious to list all those numbers. So we use this approach that we're going to see in a minute. So use the approach, sorry if it cut it off on your paper too. Use the approach shown in example 5. You have to factor both numbers. And you can't see that, and I apologize. Okay, so if you need to pause this to write this down, feel free to do so. Alright, so moving right along, use prime factorization to find the GCD. So, just one moment. Alright, so we're going to find the GCD of 600 and 540. Okay, so we know since it ends in 0, 10 will work. So that's 10 and 60. So that's 2 times 5. And this can be, you could have done 100 times 6. That would work too, but I did this, so we'll just go with it. And this is 5 times 12. And this can be 3 times 4. And you can go about it different ways. So that stop, that stop, that stop, that stop, that. So what we have is 2 to the third times 3 times 5 squared. Okay? So now when we do this one, we have 10 times 54. So this is 2 times 5. We can stop with those. 54 is 9 times 6. The 9 can be broken down into 3 and 3 and stop. 6 can be broken down into 2 and 3 and stop. So we have 2 2s, we have 3 3s, and we have a 5. Okay, so now the way we do this is we only use common factors. So the numbers they have in common with smallest amounts. And that gives us our GCD. So our common factors are 2, 3, and 5. They both have them. The smallest amount you see on a 2 is a 2. The smallest amount you see on a 3 is the singular 3. And the smallest amount you see on the 5 is the singular 5. So this is going to be 4 times 3 times 5, which is 12 times 5, which is 60. So 60 is the GCD of those two numbers. Okay? And that's how you do GCD. Now, least common multiple of two natural numbers is the smallest natural number that is a multiple of both numbers. So instead of listing the factors, we could list the multiples of both numbers, then choose the smallest common multiple. Okay? Like this. So the multiples of 8 are 8, 16, 24, 32, 40, 48, and let's see if we've listed enough. The multiples of 6, 6, 12, 18, 24. So we don't need to go any further. Okay, so that would be the LCM. However, for larger numbers, we can use prime factorization to find the LCM, similar to the way we did for GCD. But instead of using the common factors with the smallest amount, we're going to use every factor with the highest amount. Okay? So, looking at these numbers, okay, I'm actually going to use the shorter way this time to break that one down. It's 10 and 10, 2 and 5, stop, 2 and 5, stop, 6 is 2 and 3, stop. Okay, 54 was 10 and 54. This is 2 and 5, stop. This is 9 and 6. 9 can be broken down into 3 and 3. We stop. 6, 2 and 3, and we stop. So here we had 2 cubed times 3 times 5 squared. And here we had 2 squared times 3 cubed times 5. Okay, so this time for LCM, use all numbers and the highest amounts of each. And that's your LCM. So I see 2s, I see 3s, I see 5s. It doesn't matter if this one over here had a 7 and this one didn't, we put a 7. Okay? Then the highest exponent. So the highest exponent I see on a 2 is a 3. Highest exponent I see on a 3 is a 3. And the highest exponent I see on a 5 is a 2. So 2 cubed is 8. 3 cubed is 27. And 5 squared is 25. So when I multiply all those together, that gives me 5,400. So the first number in the multiples of these that they would have in common is 5,400. Okay, so LCM should be bigger than these two numbers, or at least the biggest one. And GCDs should be like smaller than those numbers. Okay, so just so you have this all in one place to calculate GCDs, you need the smallest powers of any primes that are common. To calculate LCMs, multiply the largest powers of all the primes that occur in either number. Okay? So, if we look and see what we see in example 5, look what we notice. We use this. You see that we use the circled factors to get the GCD. And we multiply the box factors to get the LCM. This means that the GCD times the LCM gives us the product of those. So which ones you don't use for the GCD are the ones you use for the LCM. Okay? So another way to say this is, once you have found the factors that make up the GCD, the product of the remaining factors is the LCM. Okay? All right. So here we go. So let's go and do, assume that you have found the GCD of 480 and 1320 to be 120. Okay, so the GCD of 480 and 1320 gives us 120. Remember that if we times this by the LCM of the two numbers, we're going to get the product of 480 times 1320. Well, we don't know this, right? So we don't know that. So it's 120 times a question mark. So when we have a question mark, normally we use an X. We can do 480 times 1320 on our calculator, and that gives us 633,600. So now we divide by 120, and X would be 5280. And just like that, we can find the LCM without having to do all the calculations. Okay? So, we find applications of the GCD in situations where we want to take several large objects and represent them with smaller objects. For example, a clerk in a store may want to arrange a few large stacks of dishes into several smaller equal stacks. Or a cabinet maker may want to cut several boards of different lengths to make smaller boards of equal size. Okay? Now, The LCM, let's see if I have a different color highlighter. We'll see if this one works today. LCM occurs, for example, one person has every 5th day off and another may have every 6th day off. And we ask when both will both be off together. Okay, sorry, that highlighter is not very good. I'll let it dry out. Okay, so LCM is when you have two things and you want to know when they'll happen together. And GCD is when you have something large and you want to make something small from it. Okay. All right. Assume that the bullet trains have just departed from Tokyo to Osaka, Nagata, and Akita. If a train to Osaka departs every 90 minutes, and a train to Nakita departs every 120 minutes, and a train to Akita departs every 80 minutes, when will all three trains again depart at the same time? Which is this, an GCD or LCM? So did they take one big thing and make it into smaller things, or did they have individual things and they want to know when it happens at the same time? Yes, they want to see when it happens at the same time. So this is an LCM. Okay? So what we need to do is find the LCM of these three numbers. So we're going to do our little factor trees. So 9 and 10. This breaks down into 3 and 3. This into 2 and 5. So this is 2 times 3 squared times 5. This is 10 times 12. This is 2 and 5. Stops. This is 3 and 4. That stops. 2 and 2. And you could have done 2 and 6 here. I mean, like, it all works out to be the same. So it's 2 cubed times 3 times 4 times 5. I mean, not 4. What am I doing? And 80 is 10 times 8. That's 2 and 5. Stops. 2 and 4. That's a stop. And this is 2 and 2. So I have 1, 2, 3, 4, 2 to the 4th times 5. So remember with LCM, everything highest power goes against what you think lowest would be, okay? So everything you see, I see 2s, I see 3s, I see 5s. Highest power on a 2 is a 4. Highest power on a 3 is a 2. Highest power on a 5 is a 1. So this is 16 times 9 times 5. This is going to be 720 minutes. Now, we don't talk in those terms. So how many hours is that? So we do 720 divided by 12. 720 divided by 60. Hello, I was doing the division and then writing the answer as my division. 720 divided by 60, and that gives me 12 hours. That's when they'll all depart at the same time again. Okay, and that's all we have for today. Let me know if you have any questions. Thanks.